Okay, our problem number 3 now. All right, suppose s and t are integers. I'm seeing there's an equation relating s and t. They said me s is between 5 and 20, and t is between 5 and 20 as well. Find the solutions to this problem over here. Right, so let's go to the whiteboard. And again, can't emphasize enough times, have the question in front of you. And this is number, I gotta find it myself. This is number 4. I'm sorry, number 3. What do I know? I know s and t are integers. That's a given. I know the s is between the integer 5 and 20. And I know the t is also between 5 and 20. All right? Give me an equation that satisfy these integers. I'll write this down for you. S, and then it's going to be the root of s minus t is equal to t, and then it looks like the root of 2t plus s. All right, one thing I do know about this over here is that s has to be greater than t, or equal to it. Make sure I copy this down right. So I got s minus t, 2t plus s. Yeah, I think I'm okay. All right, let me see if I can do now. And you may wonder why I know s is greater than t. I'm looking at the root of s minus t, and I know that's got to be a non-negative number. All right? So what I'm going to do is I'm going to square both sides, and you get s squared, s minus t. That's going to be t squared, and then you're going to get, let's see, 2t plus s. All right, at least I got rid of the roots. Again, I have conditions that need to be met over here, and that the fact that these are integers too. So let's keep going. You're going to get, I guess you'll get s cubed, right? So let me make sure I'm doing that right. And I'll put this over at s cubed minus s squared t. And this is going to be 2t cubed plus s t squared. I always wonder what to do with this, but I'm looking at this thing, and I'm going to use, try to get this to be equal to 0. Let me see if I can do that. And I'm going to do s cubed minus, I'm going to borrow 1 from this because I see a difference of cubes now. And then I'm going to say, if that's true, it's going to be minus t cubed now. So I did this, I did that. Let's keep going. So minus s squared t minus s t squared is equal to 0. Right, I'm looking at that. I'm going to continue to go forward on it. And I'm going to factor this guy here. And I'm hoping I'm seeing something when I factor it. So s minus t, s squared, plus st, plus t squared, minus, and I'm looking at this now to factor this guy over here. And the first thing I notice is that there's definitely I could pull a t out, right? I think I can do that. And what do you get there? T squared plus s squared, and then plus, I'm pulling a t out, right? st. That equals 0. Well, lo and behold, I'm noticing that this guy here and this guy here, it's really the same thing. It's t squared plus s squared plus st. So I'm going to factor that out now. So I'll write down s squared plus st plus t squared. And then we left off with s minus t is equal to 0. All right? So let's see if I can make that a little bit simpler. And yeah, I think I can. I can say s squared plus st plus t squared. And this is s minus 2t. This one looks pretty easy to deal with, by the way. I would say that s is equal to 2t. And does that make sense with this up here? It does. It says s has to be greater than or equal to t. And we'll go through that in a moment, by the way. But I'm looking at this one over here. I'm wondering what this one's going to produce. And I'm going to say it's quadratic in S or t, but I'm going to solve for S. I want to see what happens. Twice the coefficient on the square S term, which is 2. 2 times 1 is 2. Let's see, and then it's going to be the opposite of the coefficient on that linear term, which is S, that's minus t, plus or minus. It's always confusing, all those letters, isn't it? Let's see, t squared minus 4 times 1, and then times t squared. And that sounds pretty strange over here, don't I? S equals minus t plus or minus, let's see, minus 3t squared over 2. Well, the only way this could be true, because again, remember that these must be integers, t has to be 0. And that's not a possibility, by the way. And why do I know that? That they told me that the t was greater than 5. So this is out of the question, by the way. So I'm left with this one over here, right? So I'm going to write down as an ordered pair of numbers now. I still have to check it. And someone said, what are the ordered pair of numbers? The ordered pair of numbers are going to see st. And then the question comes is, what do you write down? And this is the part where I have to start thinking about it. And I want to go back over here. And I know the S is between 5 and 20, and the T is between 5 and 20, right? So the S is between 5 and 20, and the T is also between 5 and 20, right? We're as an ordered pair. So if T is equal to 5, the S would be 10. The condition needs to be met over there, by the way. So if the T is 6, what would you get over there? You get 12, right? 7. I gotta be careful over here. 14, right? 8, 16, 9, 18, 10, 20. By the way, I can't go beyond that. I'm gonna put a little box in this over here. And someone says, what are you gonna do now? I'm gonna check in the original equation. All right, what's the original equation? I'll write it down again for you. And the original equation is this one over here, S. Boy, I made a mistake already. The root of S minus T equals T 2T plus S. All right? Let's try 10.5 first. And again, remember the ordered pair is ST. And we're going to try 10.5. I want to make sure it works, by the way. 10. And S minus T would be 5. 5. Let's write this one down. What do you get? 10, 20. All right? Well, looking at it, I'm going to say this is true because square root of 20 is going to be 4 times 5, and square root of 4 is 2. Yeah, it looks good. Let's do the next one. The next one's going to be 12, 6. 12. And let's see, 12 minus 6 is 6. What do you hear? 6. And then what do you get there? Well, 12 and 12 is 24. This works as well because, again, there's a 4 and a 24. Square root of 4 is 2, and 2 times 6 is 12. Looks good. Let's do the next one. That's going to be 14, 7. You get 14, root 7. What do you get over here? 7. And what do you get there? Let's see. You get 2 times t, which is 14. 14 and 14 is 28. And again, there's a 4 there. Square root of 4 is 2. Yeah, it looks good. All right. Let's do the next one, 16, 8. What do you get there? 16, 8. What do you get over here? 8. And root, that's going to be 632, right? Again, the 4 is there. Square root of 4 is 2. 2 times 8 is 16. Looking good. Everything looks really nice. Nice and easy to verify, too. 18, 9. 18. 18 minus 9 is 9. What do you get over here? You get 9. 18 is 36. Also easy to verify. It's 3 times 18. And 3, let me write that down for you. This is really easy. 3 times 18, and the other one's going to be 6 times 9. And 3 times 18 is 30, and 24, 54, and 6 times 9 is 54. Last but not least, we got 20, 10. We're checking original equation. That gives me 20 root 10. What do you get over here? You get 10. And then over there, let's see, you get 20 and 20, which is 40. And again, there's a 4 there again. Square root of 4 is 2. 2 times 20 is, yeah, it looks good. It looks good. Everything looks good. So these are the answers over here. And we're done. Thank you.